repository that you can all take a look at after the talk. Je peux. 1, 2, 3. 1, 2, 3. Plus haut. 1, 2, 3. Maintenant, ça marche? Hello? Okay. Hello, everyone. We'll do another start. Okay. Hello, everyone. We'll do another start, and today we'll talk about GraalVM, and the format of this talk is different from what I was doing before. Usually, before it was slides, either code or a mix of both. This time, I decided to go purely in GitHub, and I've created a repository, and my actual slides will be the README files or the Markdown files, and the demos are located inside the Quarkus and Spring Native folders. So you'll be able to consult them later whenever you want, because it's a free and open source repository, so don't hesitate. You don't have to take lots of notes, because there are quite a lot of notes in the documentation. So just know the repository and look for yourself whenever you think it's suitable for you. Let's start. This was a small introduction. Let's start. My name is Rodislav Moldovan, and I'm a software craftsman. I'm working for the Bill at the moment, and I'm doing Java for lots of time. Java, Linux, and JavaScript, and all the crazy stuff. As well, I'm doing Docker, containers, Kubernetes, and why I'm doing this introduction is because this will be important during the GraalVM talk. GraalVM is not just a VM that helps make Java faster. It makes Java much more easier to use, especially in the containers. But we'll see that along the way. So what is GraalVM? Usually I like to say it like this. GraalVM is about how to drink the holy water and not choke. It's a way to have a speedy Java with relatively not big efforts. So GraalVM and native images. GraalVM is a suite of tools. We have here a JVM, an actual JVM version of a Java virtual machine GraalVM version. We have a JDK that allows us to compile stuff, and comes with a bunch of tools to build native images. And when I'm saying native images, I'm speaking about binary applications that can run natively without dependencies, meaning without JVM as a dependency in the system. So for those who did Go, it's the same as doing Go. So the result, the compilation process and the resources to compile are different, but the result is the same. So GraalVM has its roots in the Maxine virtual machine project at Sun Microsystems. So for those who just started doing Java, there was a company called Sun Microsystems who promoted Java in the first place. GraalVM was built, the roots of GraalVM were built there, and the idea was to write Java in Java, the Graal of the things. Now, today, GraalVM with native image is a tool, a native image from the GraalVM suite is a tool that can give us ahead of time technology and can produce executable binaries of the class files. So it's not a jar, okay? It's not an actual jar. You cannot unzip a binary. I mean, you can decompile it, or you can hex edit or do stuff like that, but it's not a jar that you can open with 7-zip or WinZip, and it won't work like that. And the resulting binary includes the application classes, the .class files, the dependencies. So it includes everything, and normally it's expected to include only the files needed to run this particular application. That means as well that some of the features were not present in native images that we know and are familiar with in usual JVM. In JVM, we can run an application, and then inside this application, load another application who is going to generate code in runtime, do lots of stuff, can do dynamic linking, lots of things. This potentially can be done, but it will be very hacky way. The idea here is to take an app like we'll do in C or in Go, compile it, and it will work like this. I know this can seem like a limit, but today if we build Quarkus applications and Spring Boot applications, this is what we do. We have a framework, we have our code, we have a Tomcat or a JT or something like that running behind the doors, and that's it. We don't really do WebSphere, JBoss, blah, blah, and other stuff that loads applications, that load them at runtime, and all the stuff. It's really straightforward. It's an app, starts, it crashes, starts, it crashes, or it stopped, it doesn't matter. It's one app, and that's it. So we'll talk about that. We'll switch to demo, but this time I decided to talk about a couple of things first, and we'll see during the demo what exactly I'm talking about. I've decided to put the main actions, the main questions in front and just announce them. So the eternal question, is GraalVM ready for prod? I mean here prod and PRD, like quite often I see people doing, calling the environments with trigrams. So the GraalVM, yes, it is ready for production. It is used today to do stuff in databases like Oracle, Postgres, and so on, to do drivers and lots of stuff. So if you heard that you can write Java code for Oracle that will do some functionality, you can, and you can do it with GraalVM to make it super fast.
One question from the audience. Does it mean that what you build with GraalVM, if you decompile it, you have really assembly code, it's really native code that is built?
Yes, you'll see traces of class files and stuff like that. It's very close to a native code built from C++. It's not exactly 100%, but it's very, very, very close because you still have a garbage collector inside. You don't have a JVM inside, but you have the tooling that exists in JVM inside your binary. So you have a garbage collector, you have a memory management in general, and some other tools, but we'll see right away. You cannot really, I mean, you can if you want, but you won't really, hex editor will be the best way to alter a binary if you really want to.
So you cannot decompile your bytecode?
Look, everything can be done, but the question is, does it worth it?
I think it's a feature, it's good.
Yeah, yes. So, Quarkus, ready for production. In very short ways, there is a framework called Quarkus. It's like the grandchild of Java Enterprise Edition. So Quarkus, yes, is ready for production. It runs in production today in lots of projects. Quarkus is not as popular as Spring Boot, but it's very close by strategy. Now, the question, is Spring Boot ready for production with GraalVM? The answer is soon. Today we have Spring Boot .4, Spring Boot 2.4, 2.5, and so on. 2.5 is in progress. And the Spring Native, the support for GraalVM and Spring Boot, is in beta today. It will be in production and like 1.0. When Spring Boot will be released as 3.0. When it will be, there is no clear schedule, but I saw a talk with Sébastien Deleuze, who is one of the lead developers on the project. He said that we can expect it by August, but maybe later. There is no clear roadmap for that. So Spring Boot will be ready for production soon. Quarkus is ready for production today. Where we can use GraalVM? We can use it today for CLI, command line interfaces, apps, tools, command lines, I don't know, something. Microservices, lambdas, and what I call microlit, meaning a microservice that is not really a microservice. A microservice that can as well do some other stuff. It's not only a user service, but a user service who can do transaction management for Forex transactions, or I don't know. It can be larger. So that will be a microlit. You don't have to use it. I mean, you can technically, but it will be not a good idea to use it in big monoliths because it will require you, and I'll show you what exactly it will require later, lots of resources to compile. It will take really long time to compile. And don't use it for legacy because you'll have too much trouble with that. So don't to me, that will be a waste of time. CLI, microservices, Lambda, and microleads. So let's start with Quarkus. Today, GraalVM can be used with Quarkus, and why? Because Quarkus took GraalVM as the main stage for building and running and deployment. So Quarkus is built around GraalVM. Everything in Quarkus is done with GraalVM in mind. The moment you have a feature, the feature should be compatible with GraalVM. It's a must. There are features which are not, but Quarkus insists that every feature should be compatible. So when you do Quarkus, you are like 95% guaranteed it will work out of the box. Sometimes you might tweak and tune, and then it will do the job. So how you start Quarkus? I don't know whom of you are, I'll show before here. So when you start Quarkus, I don't know if some of you are familiar with NPM and starters like Start Spring IO, Angular NG, Create React App, and so on. Quarkus have the same. It's called IO Quarkus Maven plugin. It can be invoked with Maven to create a project. Yes, you have a question? No.
If you want to react, you can put thumbs on the chat.
So let's do it like this. I think the chat will be bigger, the images will be bigger, it will be easier to read. So Quarkus gives us a possibility, gives us a Maven archetype that can create a Bootstrap project. You have to specify the group ID, artifact ID, the class name, the main class name that is going to be executed, and a path. And then it will do the magic start for you. This is what I've done in my project. So when Quarkus, I think I have to do something like appearance, enter presentation mode. And then I can do like that, and then like that. Is it readable? Is it readable for you here in the audience? Okay. Yannick, if somebody says about readability, I can increase the text or... So what Quarkus does, once you run the command, it will give you a project, just like Start Spring IO gives you a skeleton structure. And you'll have in here, out of the box, some of the very interesting elements. It will give you a Docker ignore, which is quite unusual to have a Docker ignore, meaning that Quarkus is by default oriented for containers. It will give you a POM, MVN wrapper. For those who don't know, MVN wrapper is a utility who is capable of downloading a special version of MVN to your project and run your project with the right version of NVM. Something like npm install and then a certain version of Grunt or similar stuff. Now, what it will give you as well, it will create you the standard SRC folder. And what's very important, it will give you a bunch of Docker files. Docker file that can use a Java minimal thing, and then it will run your application. A Docker file for legacy applications, for native stuff, and for distroless Docker file. So why this is important? It's very important is because the distroless, it means that basically you can run Quarkus in different ways. You can run it as a legacy Java application because you want that, but this will mean the Docker image will download all the JDK behind the doors because it's based on a JDK within distribution with JDK inside. As well, if you build everything in native, you can use a minimal distribution, a minimal Linux distribution that, if I'm not mistaken, still have a bash inside. And as well, you can use a distroless distribution that is very light, is very small, and will keep inside exclusively, and just like literally exclusively, one single file. And that single file will be your app. And as you observe, you don't have any jar extensions. It will be just a binary that is going to be started. when we speak about binary application, those native images, you see in this particular Docker example, we still can pass parameters with -d, meaning that when we use a framework and we build a native image, we do not lose the capacity of passing parameters. I mean, we still can have the fast image and we can configure the fast image. I mean, if you deploy something and you want to configure with environment variables, it will work out of the box. You don't have to work it around, you don't lose features. That's the idea. In terms of POM, there are a couple of very important elements. As we see here, Java 11, meaning that you can use with GraalVM Java 11. With Quarkus and GraalVM, it will work just fine. There is a possibility to run it as well with newer versions of Java, like 16, 15, and so on. 15 is not anymore supported with 16. But I haven't tested yet. I tested it precisely with 11 because it just works. Some of the very important elements that we see in the POM. Just one moment. No. Right. So what you'll have a profile that will be configured, or will configure your build to build a native image. And will configure with everything inside. It will give you all the right parameters out of the box for simple things. It can be that at some moment you need to parameterize the execution of the plugin, the failsafe plugin, or for your integration test or for any other tests. It can be, but it really depends on what you build. Now, if I'm going to resources, you'll get the usual application resources that exist in Quarkus. Quarkus has the same principle as Spring Boot. You have an application resources, and you have a bunch of parameters that you can use, as you see as well, like the host, the port, everything you want, just like you'll do in Spring Boot. So exactly the same principle. However, one big difference between Quarkus and Spring Boot is that you don't have, by default, the main application class. Quarkus works a little bit different, so if you really want, you can do it. But by default, you declare your sources. Let's imagine you are creating a web application. You declare your sources and you start coding. And as you notice, you use the familiar from Java EE annotations from JAX-RS, like get, produces, path, and everything you want. As well, what is important, we still have injection. So again, when we use Quarkus, we keep like most of the features that we know. We have beans, something equivalent to Spring Beans or AGB. We have injections, we have services, we have lots of features that we are used to and we love doing because it's easy to code, it's easy to test. You have all of that and it just works. And you have a greeting, yes, here is a greeting service, a very small application. So what we'll do now, we'll start this small application. Right, before we start this small application. Normally in a Spring Boot application, you have an application class where you do right click and then you do run, regardless if you have Intellij, IDEA, Eclipse, NetBeans, or VS Code, you can do just run. You'll have a run button here, or you'll have run everywhere. In Quarkus, you don't have that button because you don't have a public void static class. Such thing does not exist by default. You can do it, but it does not exist by default. So what you can do in this case, it's called plugins. There is a tool developed by Red Hat. It's called Quarkus Tools for Intellij IDEA. You install it, and then this tool will give you a runner that is called Quarkus, where you can run your application with Quarkus and have the app running for you. What this application does technically, it, right, I have another, yes, of course. I have another application running inside the terminal. One moment, I'll just, I have my port busy, but I don't remember with what. Yes, I remember now. I think the code is still visible, so for now we can keep it this way. So let's run the application again. No, I don't want to. Appearance, exit presentation mode. Then say appearance, enter presentation mode. We'll do like that. Ah, right, okay. One moment, I have a small issue here. Okay. Doesn't work for me. It's something like a demo effect. I'll do the things a little bit different because I have a little situation here. Okay. My Intellij is getting buggy and I don't know what. Why. I'll do it differently. Now I'll just reduce the code. I'll change the size of the code in this way. Okay. You know, it's the moment when I'm changing the code and it doesn't change the code of the editor as well, of the font. Okay. Can you tell me if the code is still readable, because I cannot get Intellij IDEA working for me. I don't know why. Let me try to exit again. Okay, so now we have the code a little bit bigger. That should be fine. So what we have here, listening on the profile is activated. Right. Let's do a start. Let's do a restart, and let's check how time it takes to run a Quarkus application with a JVM. So the Quarkus application, as you see, is running with Maven. You can run it with this Quarkus tool, or you can run it as well with a plugin. It's called Quarkus. And then you have Quarkus Dev. This plugin with Quarkus Dev will give you the possibility to run Quarkus without any problem. Now the application started in, normally they were saying, yeah, so the application started in about 2 seconds, okay? Which is pretty fast. A normal Java application with pretty much nothing inside starts in 2 seconds. Now I can tell you that whenever you are adding JPA logging, APM for Elasticsearch, for example, application monitoring, JMS or whatever, this will add a little bit more, but it will go up to 5 to 7 seconds in total to start. So it will be a regular startup time. Nothing extraordinary, nothing special. So what we'll do now, we are going to launch an application that was built with, already I'll stop this one. And I'm going to start an application that was compiled with GraalVM. And let's do that. So if the previous one was 2 seconds, the second the second run with a native image started pretty much instantly. Usually when we time the execution of such an application, it's pretty low. So as you see, we have like 14 seconds, and we start exactly the same application. Now this can be magic, this can sound magic, and the question is, what if I'm adding JPA and all the previous features that I've mentioned to my application, like to a real life application? When you are adding all those features, you'll get a much slower bootstrap time, a time that will take you about 250 milliseconds. I never saw it slower than that. I saw it 255, 257, 250, but never slower than that. It can, maybe it can go slower only if you have a hard disk drive and not an SSD, but it will be fast. It will be just freaking fast. So it's 14 milliseconds. Now we can say this is a pure hello world application, and this is not false. This is absolutely true. However, a lambda expression or a lambda function that runs in Azure, in Amazon, in Knative, or anywhere you want, will have pretty much the same amount of code. So you'll have a path where you declare your code, and you can have a service, or you can do your code exactly directly in the resource. It's up to you. You can still have a service and do your logic here. And bootstrap with your lambda will be under 20 milliseconds. That's guaranteed. Okay, so you just put it, and then you bootstrap it. Now, the biggest difference between a normal Java application, you still can, if you're using purely Quarkus with GraalVM or with their specific build of GraalVM JDK called Mandrel, you can get it to around 250 milliseconds to boot, a pure with JVM. That can be done. Now, lambda functions, they need to be bootstrapped even faster, because every lambda, you have like a flow with 10 lambdas, every one booting 200 milliseconds. Just to bootstrap the thing will take you 2 seconds, only the bootstrapping. Now, if you do this, you have 14 milliseconds, or maybe 20 if it's bigger, and I don't know how big this can be. So you'll get a 40 milliseconds bootstrap, which is pretty fast and pretty cool. Now, the question is how to get, how do I build it? I mean, if I build it, what do I get? That's a pretty valid question. What I'll do, I'll change the runner that I'm using for my build tool for Maven. Yes? It's okay? So I have GraalVM here, and I'm going to do a clean package. I'm going to skip the test because I'll just do assimilate just a build. Tests are not important for this talk. I just want to mention that testing is possible absolutely like any other testing. You can do unit testing, integration testing. If you want to build your image and then run test against a built image, it's possible and it's very easily to do. So all of that exists. Now let's build the image with clean package. And why I'm building the image live together with you? Because I want to show you some of the things. First, I don't know if the audience here, but it's the cooler of my machine. Do you hear how it started to? Because when you're building a bigger application, sometimes I was having an impression that my laptop was trying to, to lift off from the desk. So now I'm building a normal application. And just to bootstrap the build process, it is using almost 1 gigabyte of memory for a hello world application. Okay? This isn't big, this isn't bad or good. This is the way it is. It takes time. And look, it went up to 325 gigabytes of RAM. So meaning that it can take resources. In other words, whenever you are doing development, you can go even, usually for a hello world apps, it can go up to 6 gigabytes of RAM, but a fully fledged JPA application with everything inside, from my experience, it went up to 9 gigabytes of RAM, that's it. Okay. However, when you build such an app, you can start it with 35 megabytes of RAM. Okay, you can start with 50 megabytes of RAM. With everything inside, it will work without absolutely any problem.
It's a bit like in GWT at the time when you were cross-compiling your Java to JavaScript. It also took a huge amount of memory to build the target.
Yes, exactly. Yes.
You had to compute all the dynamic objects and all the combinations.
Yes.
I guess you had the same kind of issues here, but you need to compile a lot of things inside of your application.
Exactly. So what Quarkus will do, it's a big difference from how Quarkus is treating things, vice versa, if we compare it Quarkus with Spring Native. As Yannick was saying from the room, it will, the JVM, the JDK with all of the tooling, Quarkus will do pre-processing of sources, compilation, then post-processing of sources to optimize everything at maximum it can be done. So this will take time. Scan every single class, create all the liaison that should be done in memory, everything. It will be everything translated into something that you would have done by hand. Because today if you run a simple Java application, it's fast. It's as well fast, it's almost instant. So Quarkus is doing the same. At the end what we have like this amount of milliseconds, which translates into around 2 minutes. And we have this amount of RAM that was used to build this image. So just to give an idea, whenever you are developing apps for GraalVM with Quarkus, with Spring Native, you just develop with regular JDK. Just code the thing, run it with JDK. As we ran before, it will start in 1 second, 2 seconds, something like that. Regular stuff, nothing extraordinary. Now, if you want to test it before pushing to a source control, you can do a build. You do a build and have a tea or have a coffee, okay? There are no options. It will take time. But it's not something that you'll do regularly after each build. It doesn't meant for that, okay? Those kind of build. Today, it's not slow because the technology is bad, but it is slow because this particular technology is applied to frameworks and is not yet finished and very polished. It can be done better. It will be done better because they decreased the time and the speed of compilation very much in the last years. So this can be done easily in some Jenkins or Bamboo or TeamCity, it doesn't matter. You just build them somewhere and then run the tests and voila. It will work as needed. Usually when you run an application with a runner, that's the only dependency you need for your Docker container or for your container, OCI container. If you are using a jar, you still need the JDK, meaning, by the way, what we can do, we can compare the sizes, just to give you a rough idea. So the native runner, the native image, has 40 megabytes of RAM, okay? The jar has like 6 kilobytes. But if I count as well all the dependencies, and all the dependencies normally should be those, 70 files, yeah, it can be about 10 megabytes of RAM. So at first sight, the native image is bigger. However, this, with all the dependencies, yes, here, it will be around 280 megabytes plus your size. So you have around 300 megabytes, the whole image for one application. While this one is a single binary that either you run as a container, either you run as an app, command line app or user interface app, it doesn't matter. You can do both. However, with the user interface, I don't know if the Swing is supported or JavaFX, but you can do web user interface for desktop, and that can work as well. So now what we'll do, we'll compare this build of Quarkus with Spring Native. Before going to to that, we are going to see some of the elements, some of the key elements. So whenever you are doing a first Maven package or clean package, what you'll notice, you'll have a folder called Quarkus app, and this will be the folder where Quarkus is going to build all your dependencies. So the moment when you develop, okay, what will happen? Quarkus is going to build only your Quarkus jar and only your app. and the libs and will stay the same. That will speed up your decompilation process very, very much. Okay, Quarkus don't have to create a jar every single time like Spring Boot does by default. If you are familiar with zip, the Google tool zip is the same. Google tool zip does the same. It puts libraries in one folder, your classes in another folder, and then the compilation goes super fast. Now, this is what we see first time. Now, if we really want to create a Uber jar, like a fat jar in Spring Boot, the same, we can do that. And in order to do this, in our application properties, we have to say that our packaging type should be a legacy jar. And then Quarkus is going to build for us a Uber jar, a big jar, big fat jar, that will contain all the libraries inside the jar. This won't be a native image. This will be a jar, like a Spring Boot jar with everything inside. About 65 megabytes of RAM, the initial size, something like that. I don't exactly know the size, I don't remember. But it will be a batteries included jar. Java minus jar, and it does the job. You still need Java though. Now, guys from Quarkus, they decided to create their own build of a JDK, of GraalVM JDK called Mandrel. And it's built upon GraalVM CE. So what means CE? It's Community Edition. You have to know that GraalVM comes in two packages, Community Edition and Enterprise Edition. Community Edition gives you all the features. Enterprise Editions give you some extra tooling to tune up your stuff. So if you are going in your enterprise full on GraalVM, it's a really good idea to go on Enterprise Edition because you have support, blah, blah, special tools to trace, to investigate your apps and whatever. As well, if you have Java agents, I'm not really convinced they will work. Okay, in Java, normally you say Java minus jar, your jar, and then you can say minus minus Java agent and put an agent. For example, like Elastic or Dynatrace. With a native image, I'm not sure this will work. Okay, Elastic, APM from Elastic that does instrumentation can be added as a dependency, and that might be working. I haven't tested it. So instrumentation can be different. I'm not familiar with how it works in details. So regarding Mandrel, Mandrel is a specific JDK distribution, supports only Java 11, and it works exclusively in Linux. So Mandrel can be used to build native images for Linux, period. With GraalVM, if you want a binary for Linux, you build it in Linux. If you want a binary for Windows, you have to build it in Windows. That's very important. And in Windows, you have to download the Visual Studio C++ redistributable packages, something like that, which are free for deployment and packaging. However, they require internet. But still, you can create an offline installer if you really want to. So, and for macOS, obviously, you need the JDK, GraalVM JDK for macOS to build something that runs on macOS. While everything, like 99% runs on Linux, just use Mandrel and it will build for you. Now, when we run the build, the Maven package in the native format with a regular JDK, let's imagine you don't have GraalVM JDK, and you have you don't have Mandrel, you don't have anything. What will happen? Quarkus will try to identify, is there a GraalVM? No. Okay. The existing JDK, does it have a native image binary? Because you might have your own build of GraalVM. No. It will try to install it. It fails? Okay. Then what Quarkus will do, it will download for you a container image with GraalVM inside. Let's imagine you have containers, and then we'll build your app inside the container. So basically, you have lots of support to build native images out of the box. You don't have to play around and lose time. However, again, it will take you some time to build, some time and some resources to build your image. Okay, it can be expensive. When you're using Mandrel, Mandrel has by default all the needed tools integrated. So it will simply build your image directly with the native image tool. It will take you pretty much the same amount of time, roughly speaking, 20 minutes, 2 minutes or something like that. And then your app will be able to start in 16 milliseconds. So again, coding is the same, development is the same, no differences normally, but compilation and native image take resources and time. However, this can be done on remote server, and the bootstrap is very, very fast. So for a normal application, it's 250 milliseconds, which is still fast. I mean, it's that fast that your load balancer will not even notice that the server, an application was down. It's like tong tong, it restarted and it just goes, that's it. Now, we'll go back to, do you have any questions so far? No questions? Usually it's either very interesting and clear, or it's very boring, so hopefully it's very interesting and clear. So we'll go now to the Spring Native thing. Spring Native, they decided to do it a little bit different. So they rely heavily on Star Spring IO. The Star Spring IO where you build your image, so the usual Star Spring IO. So you configure everything, you select your dependencies, download your project, and that's it. It's the most straightforward thing that can be done. So what they decided to do, they decided to add GraalVM as a Maven dependency, as a plugin. Okay, so what you have to do, the moment you generate one of your projects, you have to add a dependency. And as of today, GraalVM supports Spring Native, called GraalVM support for Spring Boot is called Spring Native. So today, you have to add a Spring Native dependency, and you need to use the latest Spring Boot version. It will not work below Spring Boot 2.4.2.4.2. So it's really, really specific. And what's very important, you can add all the plugins and everything, but what you'll have to do, one moment. So what you'll have to do, you'll have to add milestones and snapshot repositories. It was written somewhere. No, yeah, right. So you have to add the milestone repositories for plugins and for dependencies. Otherwise, it will not find the right dependency. So the idea is that in your source code, you'll have dependencies that are not released versions. They are milestones, snapshot-like versions. Because the work is heavily ongoing, they did it for about 2 or 3 years now, and they are very close to a release candidate. Voila. So let's see the source code, how it looks like. So if we are going into Spring Native, what we'll see, the usual stuff, the usual Spring Boot parent, like this, exactly the same. We'll use, however, this time we'll have to add a repository, a plugin repository. We'll use our usual dependencies, Spring Boot Starter Web, Graal Native. This is the new, of course. And as you see, we use the regular dependencies like Spring Boot Starter Test is really, really the same. So if I'm going to REST application, I have exactly the same Spring Boot application, the exactly same greeting controller, the exactly same GTO class, so exactly the same. One of the differences is this. So we have to disable the proxy bin methods because the plugin will do that for us. It will decompile, not decompile, it will transform the classes so that they are instantiated directly, and there are a lot of things happening under the hood for generating to generate the app. We'll see that right away when we'll start the build. We have, as usual, the application properties that we can use. It's nothing extraordinary, nothing different from what we have. So as you see, it's a very, very much normal Spring Boot app. The only difference is this dependency. And with this dependency and with a specific profile, we enable the native Maven plugin, who is going to use a native GraalVM native to build an application. And as you see, you have to manually specify the main class. Maybe this is going to be automatic later, but we'll see. One of the differences, the main differences in their approach is that you have to specify the main class, and what you can do as well, you can disable or disable and enable certain features of the Spring framework. By enabling or disable certain features, your application will be smaller, considerably smaller, and it will be way more faster. So adding more features from the Spring framework will cost you more, not only in the compilation time, but as well in the startup time. Okay, that's very important, because those impacts are not in Quarkus. Usually the main impact is on the compilation time. Here, the impact will be really on the both. But this might be changed. We'll see how it will evolve. Other than that, the usual Spring Boot Maven plugin. You can do it with Maven. You can do it with Gradle. It's up to you. You can do it with both. And let's run the application. So let's run the normal Spring REST application business as usual. It started in 2 seconds. You see, just like Quarkus. The same with the JDK, no difference. It works like usual. Now let's do the compilation part. I check the JDK. And now I can go to Spring Native and do again the clean package, the same procedure with the native profile. So as you see, it does lots of stuff behind the doors. Let me just mute. And it takes time. It takes really lots of time. It will take roughly about the same time as the other, about 2 minutes. And we'll have as well an application that runs super fast and does the trick. And here we'll be moving to the last part soon. We'll be moving to the last part of this talk. Other than that, does it seem to you to be something interesting? Not that much? Yes?
I have a question. Does it have an impact on the memory usage?
So the question was, does it have an impact on memory usage? Yes and no, because there is a garbage collector that is put inside the native image. So it has, but you don't have to manage it by hand.
Yes, is it the same behavior as what you have in the typical GRE garbage collector, or is it a different behavior?
You can have, well, it's slightly different because you have a different garbage collector normally. There is a garbage collector called Shenandoah that is not giving back the memory. Okay? So Shenandoah will tell you no. But it's
good for short-term processes.
It's very amazing. Shenandoah, it was built for that, yes. And but you still have some good garbage collectors that will give some memory back potentially, or yeah, you normally from a developer perspective you don't have to fill it. Yeah, the memory management is slightly different, but it's only slightly, not completely different.
And the amount of memory used is the same in compiled application as normal Java application?
Much less. A normal Java application, most likely a production one, okay, with JPA, web, DTOs, mappers, I don't know, REST, whatever. It will, to properly function, you'll need to give it 256 megabytes of RAM, at least. I mean, you can give it less, but I saw weird behavior. Usually it's 512 XMX. Now here, you can give it 35 megabytes of RAM. It will boot and it will work. You can give it 64, blazing fast. You'll have absolutely no problems with it. unless you serve with your application big files. If your application is supposed, for example, to serve images that has like 10 megabytes of RAM, then yes, you'll have a problem if you don't have enough memory. But for regular microservices, piece of cake, it will be fast. And as you see, it takes roughly the same amount of RAM. In this particular case, it takes more, 7 gigs instead of 7.5, instead of around 6 for Quarkus. But again, it's a beta technology, and it's under active development. And it's really, really promising. So it took longer to compile. And let's start it and see how it behaves. So when we check the target folder, what we'll see here, the name of your app will be by default this one, so your package and then your artifact ID. Let's do the run. So it took, this Hello World application took around 240 milliseconds to boot. And that is because, there is a reason for that, an obvious reason, is because I did change the parameters in the build args. I did enable everything, all the stuff, or some of the stuff. So when you are enabling and disabling stuff, you'll get the same super fast small application, but you'll get a slower startup. That's what I was saying initially, that whenever you are adding Spring features, removing Spring features, it will increase the bootstrap time overall. But let's take an actual normal application, a JPA application. And where do we find such an application? I'll suggest you to go to Spring Projects Experimental. I put all the links inside this presentation, so you'll find it pretty easily. You have a Spring Native application repository with lots of samples for all the use cases you want. For JPA, JDBC, Mongo, Mongo Reactive, Neo4j, R2DPC. If you're not familiar, R2DPC is the reactive JDBC. It's a different standard built by Pivotal and other contributors. gRPC, Hibernate, so Kafka. In other words, pretty much everything that we use today. Okay, so you have samples for everything with the parameters and blah, blah, blah. You can mix them in order to build your particular application. Very easy to use, working samples. Question? No? It's okay. So I have here a pet clinic JPA application. So as you see, I haven't disabled the proxy. I have the classic stuff. Controller, another controller. We have models, entities. We have everything. Let's call it the business as usual. Controllers again, with very important, with dependency injection. So, and what is very important as well, we have Spring data that works. Okay, that's very important because we still can use Spring data and all the funky stuff. I'm not sure the Lombok will work though. That has to be checked, or Mapstroke. I cannot vouch for that, but they might work. And we have, Liquibase doing stuff, and no, it's false information. In this case, is the regular Spring Boot data insertion things. So what this will do if we start it now? If I'll start it now, it will take about 10 to 15 minutes to build, which I don't want to start. I built it in my own time. And to give you the idea, I think it was here. No, false. Here, yeah, most likely here. So when this application was built, I kept the log. I should have it somewhere here. Yeah. So when this application was built, a fully fledged production-like application, okay, with everything inside. No Kafka or RabbitMQ, but we can add it. So this was built in native image for about 10 minutes on this machine, and this is a i7. I'll show you. So just to give you a rough idea, so this is a machine with 8 cores, 32 gigabytes of RAM and SSDs, not NVMe, but SSDs, like a regular developer machine, nothing extraordinary. So on this machine, it took about 10 minutes. If you have a hard disk drive, or if you have less memory, or if you have a lesser CPU, it will take longer, okay? Considerably longer. And it took, for one single application, it took 10 gigabytes of RAM to build this one single application. So 10 minutes, 10 gigs of RAM, one app. So as you see, it's pretty resource consuming. It's not the end of the world, but it's still pretty relies on resources. However, when we are starting the app, the apps, right, of course. When we start the application started, we saw the logs much longer than the app started, and normally we should have the timing. Yeah, so the timing is like this. The JVM, it still says JVM. It thinks it's JVM. Started for 275 milliseconds. A fully fledged production ready application. You see? So that's the difference. That's the very important difference. And if I'm going to, for example, in GraalVM Spring Boot Native, in the target, it takes 73 megabytes of space, and then voila, it will work business as usual. So that's the thing. So again, I'll come back to the main questions. If you think to use GraalVM, you can. It's production ready, and it's a thing that we think to use as well. When you're thinking about enterprise environment, when you can have virtual machines, managed virtual machines, or developer machines managed by developers, or different cases, developers can continue to work in JVMs business as usual with OpenJDK Adopt OpenJDK, for example, or the Oracle OpenJDK or the Oracle JDK. It will work. They can continue to develop. Everything will be fine. Now, what you have in your CI/CD system, in Jenkins, Bamboo, whatever, you can have this GraalVM CE or EE, and then build native images there, and use the native images in production. It's pretty stable today with Quarkus. It works with Spring Native. It will be in release soon. Okay, soon, like as I understood, it should be August, but we'll see what future will bring us together with COVID, our friend, and so on. So if you think to use it, you can use Kotlin, Clojure, Groovy, Java, everything. You write that stuff, you compile to GraalVM, it works. You use Spring, Micronaut, Quarkus, Open Liberty, all other frameworks based on microprofile, they all support GraalVM. And you can write in both Java and Kotlin. Quarkus is added Kotlin as a first language service. So you have the possibility to use, the power of the ecosystem, choose your language, and still benefit from all the Speedy Gonzalez thing. So CLIs, small tools, microservices, lambdas, and microlits, and don't use for monoliths. Believe me, it will be very hard. It can be done, but it's super hard. Don't use it for legacy because it will be, I don't even know if this can be done, honestly. So going further, in this repository there are a bunch of links and videos and stuff to check and to do. There are people that I suggest you to follow in Twitter. That will be Oleg Shulaev, Sebastian Deleuze, and some other things. Follow GraalVM. There is a person, but I forgot his name. He's doing lots of GraalVM talks where you can learn more. Just to give you an example, there is no huge difference from today's way. You can use SDK man if you are familiar with. Are you familiar with SDK man? SDK man. SDK man is a tool to manage JDK versions in your machine. So you can install GraalVM with SDK man. And you can install GraalVM manually if you want. It's up to you. You can use it in Intellij IDEA and Eclipse and anywhere you want. It's up to you. It will just work. In Intellij IDEA, however, a tip: even if for your module you are using any JDK you want, for the Maven runner, as long as you run Maven from Intellij IDEA, you have to specify the GraalVM JDK, otherwise it will not pick the right JDK and will be just lost in the woods, okay? You have to Maven runner precisely say, use the GraalVM JDK in Intellij IDEA to make sure, to make it work guaranteed. And as you see, I've installed different GraalVM JDKs builds because there is a reason for that. Because some of the features were not working in one version, working in another. I was having like issues, a little bit here, a little bit there. But that's with Spring Native. And that's because I'm not really used yet with Spring Native. I'm very used with Quarkus. It's very straightforward, very easy to do. And Spring Native is getting there where it will be, their goal, just to put it short, is to add Spring Native dependency, and that's it. This is the main goal. Maybe add options to tweak a little bit, but that's the ultimate goal, to make it super straightforward. And this is going to happen, I'm convinced about it. So that was it. If you have questions, shoot.
There are a few questions I can maybe ask them now. We had questions about the way the system is built. You mentioned the fact that it requires a lot of resources for building. Is the strategy to use container agents to do the build something that is realistic and that could be used in a CI/CD approach?
Yeah, it's very realistic. Yeah, actually, Quarkus with Mandrel. Let me show you one moment. That would be the best way with Mandrel. They position Mandrel is the only recommended for building native executables that target Linux containerized environments. So Mandrel will be the way to go if you use Quarkus. If not, GraalVM CE, and it will just work for you as well. Yes, containerized Linux is the best. And there are images with GraalVM inside that you can use. So, yes.
Okay, another question about the security configuration in the build, because in Java you have several security at compile time and runtime that can be used to define some security behaviors of the application.
Oh, right.
Is there something that you know about related to how the default behavior is configured in a target?
I don't remember the default behavior. I just don't remember it. But I remember that there are options to set up the security stuff. I know what you're talking about, but I just don't remember it. I'm sorry, I cannot answer now. But you can write me this question in Twitter. Just tag me in Twitter. It's Rodislavable, and I will. We can look into that and find the response.
There is a last question that was about the string pooling. In the JVM, you have the strings which are always immutable and pooled.
Yes.
So for some lost short values and things like this, is this behavior reproduced in the native application?
Yes, I remember they were doing it. This was a question that I asked as well. For example, Sébastien Deleuze, he said it can be done, but there are some conditions. I don't remember the conditions. But yes, this feature can be done at least in Java 11, that's for sure. In Java 8, I don't remember the thing. But yes, this feature exists. Again, it depends on how you compile your app, because you can enable some features, you can disable them. So normally, yes. Now it depends on, and as well, it depends with what version of GraalVM GraalVM JDK you do. But yes, this feature is supported. Even reflection is supported, which was not before. But adding all those features, those smart features into your native app will make the app bigger and slower to bootstrap. So you have to choose What do you want? But yes, it can be done. Ultimately, the answer is yes. The way to do it, you have to configure. I don't recall that part. But we can find, again, ask in Twitter and we'll find a solution.
Okay.
And this repo will stay here. I'm going to work on that to add some examples, some very practical examples, and you can follow it later. And yeah, that's the idea.
Just to wait a bit, the
Yes?
stream is a bit late compared to what we have in book, so just to keep. Are you finished?
Yes, so that was it. Thanks everyone for attention. You want to say some words?
Just let me check something.
It's very hard to.
Okay. Thank you very much, everyone, for joining us today. I shut off the stream because otherwise you will have a feedback on what I'm currently saying. Thank you for joining us to this first mixed event, which was both physical at the Leisure Premium, sorry, at the Parc Bel Air Hotel today with a few persons present. Thanks to all of you. It was great to see that people really stayed over the whole exercise. So I think it was, coming back to your question earlier about whether it was boring or interesting, I must say that given the number of people who stayed until the end, it was definitely interesting. So thank you very much for this good presentation. I think it's really a trendy topic that we were all happy to learn more about. So I hope you were also happy with this. We will come back with an agenda for future conferences in the coming weeks. As I said in the introduction, we don't really know exactly how things will be moving forward in terms of conferences in Luxembourg, but we will definitely keep you in touch. Thank you to everyone who joined us for the first time today. There were a lot of you today who were never part of our events until now. So yeah, really, it was really a pleasure to meet all of you. Feel free to follow us on the different social networks, and hope to see you soon at another conference. So have a nice end of day. You can stay as much as you want to discuss or socialize between yourselves. You can have a look in the museum part of the spatial chat room. You have also a vintage poster of our conferences that 10 years ago. So thank you very much for joining, and see you soon. Bye-bye.